Hello everyone, I am Rushali Chaudhary, lecturer Praveen Patil. We are going to learn metallurgy for the applied science chemistry. We already learned different properties of metal, due to which metal is useful for the engineering or for making the machineries. Without machineries, engineering is difficult, not possible exactly. If you are software developer, even you are IT engineer, we require a machine. From that we are supplying the input. We are doing different processes to get a output which is required by our client. For any machinery we require the metals, but only metals are not sufficient to comply requirement of engineering field. To improve properties of a metal, we are using a different process. Important process is alloying. What is a alloying? A process in which metal is mixed with another metal or the non-metal to form a uniform homogeneous mixture. It's called as a alloying. Due to alloying process, chemical as well as the physical property of metals are improved. Just take an example, iron. Iron metal undergoes corrosion, but when we are using their alloy stainless steel, it will not undergo corrosion. Therefore, for making utensils at your household, we are using a stainless steel. Alloys are generally harder and stronger than pure metal, as the different size atoms make it more difficult for the layers within the lattice to slide over each other. Therefore, alloys are more tougher as well as the harder. Alloys are having a higher resistance to corrosion due to the incorporation of less active elements. Examples of alloy is stainless steel, whichever you are using at your household, brass, bronze, duralumin are the example of alloy. Why we are doing the alloying process? What is the alloy? It is a mixture of metal with another metal or non-metal. Before learning which alloy we are going to use in an engineering field, we will first learn what improvement take place due to the alloying process. It improves the hardness of metal. An alloy is harder than its base metal. Just take an example. Pure metals are soft, malleable, ductile. They are easily able to convert into different shape and size. But when we are making alloy, they become hard, difficult to convert into different shape and size. Pure gold and silver are the soft. Therefore, they are highly ductile and malleable. We can use for making a different shapes of ornament. But due to the it is very soft, it is become weak. It is not going to maintain the different shapes. Therefore, what we are going to do? We are going to add small amount of copper, due to which it become harder. The addition of small amount of copper make it hard enough to resist wear and tear. If it is a pure gold ornaments, they will not resist wear and tear. They are going to change the shape if we use daily. But if we are adding very small amount of copper, it is become very hard and easily resist the wear and tear. So we can use everywhere these ornaments. Pure iron is soft and which cannot be used for the making machinery parts. So what we are going to do? We are adding small quantity of carbon, that is makes them stainless steel, and due to the carbon, hardness of the steel is going to increases. Brass, it is an alloy of copper and zinc, while bronze, it is an alloy of copper and tin. Both are harder than the base metal of copper. Copper is malleable and ductile, but when it is converted into the brass and bronze, their malleability, ductility decreases and hardness increases. Lead is a soft metal. But when we are adding small amount of arsenic, only 0.5% of arsenic, it become tougher and harder, which is used for making the lead shots. Gun shots making, we are using the alloy of lead and arsenic. Second point is to lower the melting point. When the alloying element is added to the base metal, they will act as an impurity and melting point of base metal is decreases. Generally, metals are having a very high melting point. So there is difficult to convert different shape and sizes to convert that into the cast. It is a difficult, or molding is difficult. Therefore we are going to add alloying, or therefore we are doing the alloying, due to which melting point is decreases and metal is become fusible. So we can easily use for making the solders as well as casting properties are satisfied. The low melting alloys called as a solder alloy must have a low melting point than the metal to be soldered, and they should have the same metal as the one of its constituent elements. See, cast iron is an alloy of iron and carbon. It is used or having a lower melting point than a iron, pure iron, which is used for making the mechanical assemblage. To increase the tensile strength, when the metal is alloyed with a proper element, their tensile strength can be increased as per the requirement. The tensile strength of iron is increased by the 10 times due to the addition of only 1% of carbon. It is become really useful for making the crane, where the metal or the iron bar is used to carry a large weight. So when there is a stainless steel or the addition of 1% carbon is there, that is going to increase the tensile strength. The addition of 1% of nickel or the chromium to mild steel increases the tensile strength to more extent. To increase tensile strength of copper, we are adding 5% of silicon. So tensile strength of copper is double. Due to increase in a tensile strength, we can use metals for machinery which is able to carry a high load. Corrosion resistance. As pure metals are highly reactive metals, so due to they are having free electrons, they easily react with the atmospheric gases like oxygen, carbon dioxide, sulfur dioxide, and after that reaction it will form metal oxide. That process is called as a corrosion. Pure metal like iron, copper undergoes atmospheric corrosion. But if we alloy with suitably, their corrosion resistance is increases. As their reactivity is decreases, they are easily resist the corrosion. So alloys are more corrosion resistance than the pure metal. Stainless steel will not undergo corrosion while the iron metal undergoes corrosion. Pure iron is corroded in a moisture, but the alloy stainless steel, it is a mixture of iron, carbon, chromium, nickel, do not get strain or do not undergo corrosion. Bronze, alloy of copper and tin, is more corrosion resistant than copper. Zinc, which is readily attacked by the sulfuric acid, but the brass, which is the alloy of copper and zinc, is not get affected. The alloy of copper such as naval brass, which is having a copper, zinc, tin, and a German silver, copper, zinc, nickel, are corrosion resistant, which will not react with the atmosphere or even seawater. To get a good casting, what is meaning of the casting? When we are pouring molten metal in a mold, that metal is getting particular shape of that mold, it's called as a casting. For making good casting, metal should be easily fusible. What is meaning of easily? It is going to convert into the malleable or the molten form, that is called as a fusible. It should expand on solidification so that sharp impression can be taken, and it should become sufficiently hard on solidification for its effective use. Generally, pure metals contract on solidification. So if they shrink, it will not get the shape of mold. Therefore, alloying is added so that contraction will not take place. To get a good casting, we are using the bronze, which is used for the casting types. Printing, due to the exceptionally good properties. Small addition of antimony gives the property of expanding on solidification, while tin gives the hardness. While bronze, which is an alloy of copper and tin, and duralumin, aluminum, copper, magnesium and manganese, having a good casting property. Therefore, they are used for making statues. Gunmetal also having a good casting property. Another application is to modify a color. Different metals having a different colors, and the colors of the metal is a specific property which cannot be changed, but which can modify color by alloying with suitable element. Like the gold is having a yellow color, silver is having a silver color or the white color. But when we are making the alloy, we will get different shades. Both aluminum and tin are the silvery white color, but their alloy, aluminum bronze, copper, aluminum tin, have a beautiful golden color. Brass is the alloy of copper, which is a red, and zinc is white, and brass is having a yellow color. Silver is white, but alloy of silver and tin gives you pink color, while the alloy of gold and silver it gives you purple color. These different types of color formation or alloying we are used for making the ornaments. To reduce the malleability and ductility. Pure metals are highly malleable, ductile, hence they are having a low toughness. Therefore, pure metals are used for making articles and the shapes, and which get and their shape can be easily changed due to the small forces. Therefore, to make the metals tough, we are reducing the malleability and the ductility by using a suitable alloying element. Small amount of copper is added to the gold and silver to reduce their malleability and ductility to increase the hardness and the toughness. To change or the alter chemical reactivity. Metals have a different chemical reactivity. They are highly electropositive metals are more reactive, while the less electropositive metals are inactive. So their reactivity of metals can be modified by alloying it with other suitable elements. We can increase the activity of metal or we can decrease the activity of metal by alloying with the suitable elements. Like a sodium is a highly reactive metal, but when it is alloying with mercury, it is called as a sodium amalgam, and which is a less reactive. While chemical reactivity of the aluminum is increases with the alloying with mercury, that is called as a aluminum amalgam. Thank you so much for your attention. If you have any doubt, questions, you can mail me. Thank you so much for listening.